Welcome. My name is Matthew Lee Loftus, and Dave just gave the long introduction, so I won't dwell on the introductory slides for too long. But I am the founder of the Facebook page, The Credible Hulk, and the WordPress blog site of the same name. Here are my socials, if you don't know them, as a little sample from my WordPress website. That's where I do my more detailed posts on Facebook. Occasionally I'll do something a little bit moderately long, but it's mostly shorter posts. And this one right here, I almost decided to do my topic for this talk on this article here about the phenomenon in astrophysics and cosmology of dark matter. And I decided instead to do something that's a little bit along the lines of this one. I felt this one is a little bit too niche, but I noticed that a lot of people doubt the cosmologists and astrophysics about this because they're unable to directly detect this hypothesized substance that doesn't interact the same way with light as baryonic matter. That's what we're made of. We're made of protons and neutrons. And so I thought I would compare it to its leading competitor family of ideas called MOND, which is modified Newtonian dynamics. So it's not like nobody ever thought of, well, maybe your models are wrong. You know, it's been put out there, and there's still a small pocket of researchers that are working on different versions of that are like the competitor to the dominant paradigm, which is lambda CDM. That's the theory that incorporates Big Bang cosmology with the cold dark matter hypothesis. We've been featured in Psychology Today. It was actually my co-admin, Carolyn Aubrey's been helping me out with the page for the last 2 or 3 years or so. And she had written an article about an extremophile, these volcanic snails, and it attracted the attention of some of the columnists in Psychology Today, and they did a little piece on us. So we're slowly getting the word out beyond the realm of likes and shares on social media. So I wanted to talk about the phenomenon of science denial or anti-science mentalities, and talk about the metacognition behind it, meaning the awareness of our own thought processes, the awareness of our own biases, and the ability to kind of self-correct and micromanage the way we think about things. And I wanted to start, sometimes we don't go back to the basics of what we mean by knowledge. So I wanted to start with the definition of knowledge. Now, this is a not perfect definition of knowledge. This is what you hear about in the Platonic dialogues, and it's for a few thousand years, it's been the most well-known definition of knowledge, and that's justified true belief. So the idea is that a belief qualifies as knowledge if it also satisfies the criterion of A, being true, and B, having good justification. And I would argue that because whether something or not is true is like that's your goal when you're trying to obtain knowledge to begin with. So it's not. It may be a definition, but it's not very instructive. It doesn't really tell us how to obtain it. It just says that if it's untrue, then you can't really call it knowledge. And so, like if you believe something, but it's either not true or not justified, it doesn't count. It's not knowledge. But the one that we can do something about is this one right here. We can think about what constitutes justification. And the field of human thought called epistemology deals with different points of view on how we obtain knowledge about this or that. And the way I'm coming at it is from a sort of a combination of methodological skepticism. There have been a lot of different brands of philosophical thought that have used the branding of skepticism, and they have very different outlooks on knowledge, from ancient Greek skeptics through Cartesian skepticism. Descartes' I think, therefore I am, is a different style of skepticism. But we're using doubt as a means of obtaining knowledge, to clarify what is likely to be true, right? And we're combining that with rational empiricism. So we value the evidence from the world around us as kind of a reality check. And we use our logical processes to try to suss out what's true and what's false. And which brings me to introduce David Hume, the Scottish philosopher in the 1700s. He is known historically as a brand of skeptic, but he is also an empiricist. And one of the ideas, a lot of different ideas that are famous, but he talked about the is versus ought problem. And essentially, it's the idea that if you know what's factually true about something, it doesn't necessarily tell you what ought to be. It's not enough to say what you ought to do with that information. So my interpretation of that is that we interpret through our set of human values. We filter it and decide what ought to be the case given the factual information that we're reasonably sure is true. And so that influences my topic choices. So when I choose topics, I have basically 3 criteria. And this one on the bottom right is most influenced by this idea here, that my human values tell me that certain topics are having a massive impact on the society around me. And so whether or not they fit these other 2, they're going to be worth attacking. Because, for instance, well, first let me get to the other 2 bubbles. The technical challenge criterion simply just means that I like to improve my knowledge of things. This is like the selfish criterion right there. This is where I want to improve myself, so I'm going to do a topic whether or not it benefits anybody but me, because I enjoy the challenge. I want to try stuff that's a little bit above my current capabilities. But I also recognize that I have finite limitations, so I don't want to do a bad job at something. So if it's too far above my current education level, then I will maybe hold off on that. Because it has to be close enough to my current wheelhouse that I'm not just going to do a bad job, or it's not going to take me getting another 4-year degree before I'm able to speak coherently on it. So ultimately, I would like to hit this target, but then sometimes a topic is so prevalent that I feel it's an obligation for me to attack something like anti-vaccine rhetoric, for instance, because the impact on public health, I believe, is quite significant. And I can make it a technical challenge depending on the depth I choose to go on it. But as far as proximity to wheelhouse, I'm in biophysics, and yeah, I've had some biochemistry, I've had a little bit of exposure to immunology, but I'm nowhere even close to an expert at it. So I'll kind of let that slide a little bit for the societal impact factor. Now moving on, the problem with the is-ought, I think on not only the day-to-day level on the individual, but in society, is that if your method of determining what is true is completely broken, then you can have all the good intentions of the world, and the outcome is not necessarily going to be in line with what you think ought to be. You may want to make America healthy again, but if you're making decisions in policy that are not conducive to that because you have a faulty conception of reality, then that's not going to work very often. And that brings me to what I call the dark side of skepticism. As I said, there's been many schools of thought that have used the branding of skepticism. Not all of them are similar to scientific skepticism. And there's a phenomenon in which somebody will believe that they're being the skeptics. Like the flat earthers think that they're the real skeptics. They think, well, we're the ones who are challenging the establishment. You guys just, you agree with the scientific consensus on every topic. What do you mean? You guys are skeptics. You know, you don't challenge the CGI images from NASA. You know, so from their point of view, they're doing skepticism. But the problem is that they're applying it asymmetrically. So we in scientific skepticism communities tend to think that they're not doing it right. And it's because they're waving through ideas with very poor justifications, and they are applying impossible standards to things that do not comport with their current view. To use the concept Melanie talked about earlier, they're using system one thinking and then using system two thinking to defend it. They're rationalizing their impulsive need to believe a certain thing instead of using it to start from what is the evidence and building up to it. So we differ on what constitutes adequate justification. And one of the ways that they will try to combat whatever it is that the scientists are saying at a given point in time is they'll say, well, scientists were wrong about X. Therefore, why should I believe that they're correct about topic Y in the present? You know, if scientists believed that smoking was good for you in the 50s or something like that, you know, so why should I believe that humans are influencing the climate? Why should I believe that the vaccines are safe and effective? And it's a little bit weaselly because they're kind of taking one of science's greatest strengths and trying to rebrand it, right? Recast it as a weakness, as a reason to not think that it's reliable. And some examples of these, many of them are sort of creating like a false narrative, like a historically revisionist narrative of what happened in those instances. So instead of going into all three of them, I'll focus on tobacco and asbestos because they have kind of a similar timeline. I've also written articles about both of them that go into both the history and the faulty logic behind the usage of these examples to discount the scientific method. And they'll show pictures of doctors, well, people are in lab coats anyway, white coats, smoking cigarettes. They're essentially trying to portray advertisements as a representation, like a proxy for scientific consensus. In reality, it was much different than that. In fact, it was the scientific process that led us to understand that asbestos could increase the risk of mesothelioma. It was the scientific process that allowed us to understand the increased risk of lung cancer from smoking. And so their history is totally wrong. And then, you know, similarly with global cooling, there was this idea out there in climate change denial that in the 70s, you guys had a scientific consensus that the new ice age was imminent. You know, it was on Time magazine. You know, how could that not be the scientific consensus if it was in the media and the news? When in fact, in the formal scientific literature, it was a minority, and there was a justification for looking into it. There was a problem with the aerosols, that it wasn't actually clear which was going to win, the greenhouse gas warming or the aerosols and the resulting cooling effects. But the point is that their narrative doesn't actually correlate with reality. However, if you start trying to debunk every single one of these, you're playing a game of whack-a-mole, because they've always got another one lined up, and they won't even necessarily acknowledge that that one's been refuted. So they'll probably just go to some other public outlet and use the same argument, even though they know that somebody has pointed out flaws with it. So if you do that, you end up dealing with this, Brandolini's bullshit asymmetry principle. Okay? So that's the idea that the amount of energy needed to produce, in order to refute bullshit, is an order of magnitude greater than the energy required to produce it. And we see this all the time. We say it takes zero effort to tweet that Big Pharma is hiding the cure to all cancer, and just hit the send button and your tweet goes out into the world. Whereas if you want to do a good job at deconstructing misinformation, it takes a great deal of effort. You have to steel man the argument. You have to cite all your sources. You have to make sure your arguments are all logically sound, and it can be very time consuming. I like to play the whack-a-mole game once in a while. It's reinvigorating sometimes, but it also is kind of an endless, I have the myth of Sisyphus, here, because that's what it's like. You're just pushing the rock up the mountain just for them to throw another myth at you. And I was going to do things in a little bit different order, so I put these on the same slide. But so I might as well just talk about this, even though it's coming back later. And there was a study in 2015 about very large conspiracy theories. Grimes et al. Created a mathematical model based on real life conspiracies, because there are real life conspiracies. And he noted, at what point was the breaking point, and tried to come up with some numerical values, some coefficients for his mathematical model of when do conspiracies fall apart. And so he graphed the viability of conspiracy theories as a function of how many people would need to be participating in the cover-up in order to sustain it. And you get this shape here. This is called a decaying exponential, this shape here. And one thing I love about this is that even if you disagreed with his numerical values, thing about decaying exponentials, if the shape of it is correct, then it doesn't matter. You still get this asymptotically reaching zero as the number of participants get into the tens of thousands, hundreds of thousands. Like all the scientists in the world are bought off by Big Pharma to sell you vaccines or whatever for profit. It just doesn't work long term, because there's too many people that have to be complicit. And so you'd have to hypothesize like a degree of perfection that's just not seen. And so there's a quicker way to deal with the scientists were wrong argument, and that's to point out that it kind of undermines its own logic, right? So when they say scientists were wrong about X, how do we know that what they believed then was wrong? Thank you. Because the scientific method exposed it as incorrect or incomplete. So if their conclusion from that they're trying to get to is that therefore scientific method is not reliable, then, well, you don't actually know the X was wrong. So you can't say the X was wrong if you're saying the means by which we determined it was wrong is something that you cannot trust, that's not the way to get to knowledge. I don't know what they propose is the alternative way to get to knowledge, but they're saying that this doesn't work, therefore they can't actually know that X was wrong. But there is more wrong with this. In fact, what you see is that these arguments are flawed on so many different levels. I call it fractal wrongness. I didn't come up with the term. It's been around. Okay. But it's wrong historically. It's wrong in terms of its analysis of data. It's wrong in terms of assigning some kind of financial incentive even when it doesn't exist. It's wrong in terms of its underlying logic. And so when we get into the metacognitive processes and we can sort of police ourselves, we can sort of immunize ourselves to some degree to falling into these traps. We have to acknowledge that we all have biases. And I would say that the root pathogen of this is this asymmetric skepticism. Maybe it's not the root motivation, then you get into like the system 1, system 2 thinking again, where you have like some emotional need that's motivating you to reason in the way you do. But epistemologically, skepticism has been being applied asymmetrically. They're not credulous all around. They're credulous with respect to things that confirm their biases, and they're very skeptical about things that go against them, to the point where it's not even a fair fight. So no matter how much evidence you come up with, it's not good enough. So it's just lopsided application of skepticism. That's why we in this movement think you guys are doing it wrong. So I wanted to introduce the concept of scientific consensus, because I know that a lot of people find the concept itself to be offensive. Like if, well, science isn't done by consensus. If it's consensus, it can't be science. And if it's science, you can't have a consensus. It's all about, refuting stuff. Well, to a degree, on one level, it's about refuting the status quo. But even more prevalently, it's about the evidence. So if the evidence keeps on driving you in a singular direction, at some point, it makes sense that, well, maybe we should start exploring new questions, because we keep coming up with the same answer. Maybe some real smart person will come around eventually and think of some way that it's flawed, but it seems pretty solid based on what we know. And so what you get, I tried to break it down into what I call the microscale science, and I don't necessarily mean the spatial micro, like very small objects necessarily, but just single studies, single experiments, single data sets. And when you get a group of them kind of exploring the same question or a similar question, this microscale will involve some things contradicting the other things, and a certain amount of those will survive to this scale. We have this, you always hear the replication crisis, cited as a reason not to trust science. But when we're talking about something with a strong scientific consensus, or even if it's in the middle region, it's already past that stage. It's already, there's been replication. There has been building upon the old ideas, and still they haven't found any contradiction with it. So at the mesoscale, you have many researchers with data that more or less comes to complementary conclusions or similar conclusions. And then if you get to this level, this is like the evolution happened level. This is like the humans are influencing the climate level. This is very strong. We have thousands and thousands of studies, like from all these different researchers with different sources of funding from different countries. And so that is the most important criterion of the scientific consensus definition. It's the consilience of evidence. It's all converging on a certain set of conclusions. Now, there are two other criterion that are important for this, and one of them is this social calibration. And all we really mean by that is that scientists have a roughly equal set of standards of what they consider to be valid protocols for the field, for valid statistical methods to use in certain situations. They all have high standards, and there's just an agreement on what this entails. Some fields will be double-blind placebo-controlled studies. Of course, with the flat Earth, you can't. Okay, well, I'm going to give the sugar pill to Earth 1, and then give the real thing to Earth 2. You can't. It doesn't apply to everything. It's when you only have one tool as a hammer, then everything looks like nail type of issue. Well, each subdiscipline has to figure that out. The third one gets overlooked a lot, and that is social diversity. And all that is just a sanity check. It's just to make sure that you're not getting every single paper that gives the illusion of a scientific consensus. It's all coming from the same lab with the same funding source, and nobody's really tested any of these outside of that context. So everyone's biased in some way or another. So the hope is that if you get people from different countries, different research facilities, different funding sources, some of those biases will cancel out and you'll catch some of the errors, whether intentional or inadvertent. Somebody will catch what the other person did wrong. And so that's why that's considered to be important.
But the example is cold fusion. Cold fusion. Everybody know what cold fusion is? A couple of professors at Utah called a press conference and said they discovered a magic way to make energy forever.
Yeah, that's a great
Share
example.
the data with anybody, and then,
It's still around. It's called LEN, or low energy nuclear reactions.
Okay.
So
Yeah.
low, you can't measure that.
Yeah, I remember reading about that. One lab came up with it, and then it was science by press release. And it wasn't until later where people tried to replicate it and they realized there was something wrong. I wanted to note that there's also another flaw in this reasoning, that science being wrong about something in the past necessarily means that you're justified in rejecting its conclusion in the present. And that is because many of the instances in which there's big paradigm shifts in any given scientific field, they don't actually have a meter that flips 180 degrees wrong to perfectly correct. Rather, the new theory will sort of encompass parts of the old theory insofar as their predictions matching when the old one was getting predictions correct. And I like to use, because I'm, from a physics point of view, I like to use this as a example. Laplacian field theory didn't really have any predictions that were different than Newtonian physics. It was just like formalizing that into a field theory. So that instead of spooky action at a distance, you have a value of a field at each point in space and time. So that didn't really change very much, just the way you kind of do calculations. But enter quantum mechanics and Einsteinian space-time curvature. That was a really significant shift, but they both had something in common in that there are conditions under which these theories would produce the same predictions as these ones. For example, at low masses, low velocities, the Einstein theory of general relativity would predict the same outcomes as you would have predicted using Newtonian calculations or Laplacian ones. And similarly, Niels Bohr himself, one of the founders of quantum mechanics, he stated something that he called the correspondence principle. And that was the idea that under conditions of very large systems or very large n values, the energy values, when the spacing between the energy is getting almost continuous, that your predictions of the new, at that time new, quantum theory should agree with Newtonian predictions. So it's not like it's just, oh, well, science was wrong, and then, they just throw that out with the garbage. There's actually a lot of situations in which the old theories will get things correct if appropriately applied. And I also like the analogy of going from flat Earth to spherical to oblate spheroid, because it gives me an opportunity to introduce one of my favorite quotes from Isaac Asimov. Now, he was quoted as saying, well, I'll just read the last part of it. The punchline was that if you think that thinking the Earth is spherical is just as wrong as thinking the Earth is flat, then your view is wronger than both of them. Because it's degrees of wrongness. And that's essentially what we're trying to do, is just decrease the amount by which our conception of reality is wrong. And I wanted to circle back to this dark matter versus Mond thing I mentioned earlier, because I think that it's a good example of what a genuine scientific debate looks like, when there's actual dissent that is in good faith, and you have people motivated by things like the galaxy cluster dynamics. That's actually how the dark matter idea was first proposed back in the 1930s, was that there were some peculiarities observed in galaxy clusters, and it sort of didn't get a whole lot of attention for a while until it was later realized that galaxies, their rotation curves weren't quite matching up with the amount of matter that we were able to see in those galaxies. So it was hypothesized, well, maybe there's more matter than we can actually see, because our relativistic calculations would agree with that if there's more matter. But the Mond people said, well, that's a possibility, but since we can't detect that, what if gravity works a little bit differently on longer scales? Or what if the law of inertia itself works a little bit differently at low accelerations that you have at the exterior parts of galaxy rotation curves? And they both seek to explain the data with making the fewest unwarranted assumptions. And that's essentially what Occam's razor boils down to, is we want to not introduce more unwarranted assumptions than we have to. You know, a lot of people say the simplest explanation is the most correct, but I think a better way to think about it is in terms of unverified assumptions. We want to minimize those, but still fit the data. And nobody is accusing the Mond researchers or the dark matter researchers of a grand conspiracy. They're really actually trying to solve something. But that's not what you see with climate change denial or the anti-vaccine movement. You have motivated reasoning. You have system 2 thinking taking over and trying to justify system 1 thinking. You have ideological, political, or financial opposition to a conclusion. And they don't really have any explanatory power. Their explanations are, why am I justified in rejecting the evidence? Or accepting something that more serious researchers deem to be inferior evidence. And they will often resort to these conspiracies to explain that away, because how else are you going to do it? It's like all the climate scientists must be paid by Big Green or whatever, or they're just trying to make us all communists, or the anti-vaccine people think that Big Pharma is controlling all the science, and that anything, even if it says no conflicts of interest, it's actually secretly funded by Big Pharma because they have invoked a conspiracy theory, which we saw can only get so big before it becomes problematic. And that's when I wanted to introduce these tactics of denial. The Flick principles. Some of you have probably read about these before. And it's just a way of organizing our sort of catalog of denialist tactics. So you have fake experts, people who are framed as people you should trust on the matter, who aren't necessarily experts in that field. They might have a degree in something, but it's an unrelated field. And they say, oh, well, see, there's no scientific consensus. I found this one outlier over here that says that that's wrong, so therefore you should believe the authority. Logical fallacies. There's way too many of those for me to break down in this talk. We've all seen lists where they're all explained. In these kinds of conspiracies, one of the popular ones is the shill gambit fallacy, where it's, well, nobody could possibly disagree with me on a public forum unless they were being paid to. So you can't be trusted because you're paid by big fill in the blank. So we don't have to address your evidence or your arguments because you're paid by big fill in the blank. How do I know you're paid by big fill in the blank? Because you disagreed with me. So it's like a kind of a composite fallacy. Like you're doing an appeal to motivation. You're motivated because you're paid, so therefore you're wrong. That's a logical fallacy. It's also an ad hominem. It's saying that, oh, well, you're a bad person, so I can't listen to you because you're paid by a big fill in the blank. And it's just combining a bunch of different fallacies. But then you get cherry picking, where there might be a few outlier studies in any given field. They're going to say something a little bit different than what everyone else has concluded in their research. And so if you sort through that enough, you might be able to find one that says what you want to believe. And that's a common tactic in science denial movements. Or also the opposite can happen, where something is excluded, not because it was inferior evidence, but because they don't like the conclusion. And then, of course, we've always come back to the conspiracy theories, because there's always got to be some justification for believing that all the evidence is fake. And the reason why these work is because of cognitive biases. We all have them. The more aware of them you are, I think the better off you are. So you know that you're fallible. And but that also brings me to the fact that a lot of the people spreading this misinformation from these kinds of campaigns, whether they came from like think tanks or a particular company or a political movement, whatever, they're usually not the architects of it. They're usually sort of regurgitating something that somebody who has really thought through the psychology of these tactics has come up with. And they put that out there and hope, knowing that because people have their own individual biases, that a certain subset will latch onto that, and it's going to actually get spread from there, and they don't even have to do any more work. Now, it's gone beyond just isolated Reddit posts, fringe social media groups, because it's building up and has taken institutional power in the United States. This has happened in other places before, but it's happening here in the US now. RFK Jr. taking over the HHS is a perfect example of this. And a lot of my posting the last 2 years has been criticizing his entire crew because I think it's important. It hit that one criterion I mentioned of the societal impact. And so we're getting resurgence of preventable diseases because of some of these viewpoints that are ideologically driven. And I feel I should give some examples of this. There's like so much text on here that we don't have to like keep this up there to read every claim, but there are examples of all those FLIC principles being used by RFK Jr. and his people, like the AI hallucinated studies. That's an example of fake experts. It doesn't always have to be somebody who is a real person and is not qualified. It can be just fake research. And getting rid of vaccine experts on the panels, and assuming causation from correlation, the post hoc ergo propter hoc fallacy, and calling research that he doesn't like the results of as pharma captured or big pharma funded, even if it was funded by foreign government or even nonprofits. It doesn't matter, because if somebody is primed to believe it and they're willing to believe the conspiracy, they're going to accept that it must be big pharma. And just leaving out, there was a recent a study that was like regarding hospitalizations of people who are vaccinated versus not. And he blocked the publication of it. And the argument on his end was that the methodology didn't pass muster, but it was using the same protocol that was accepted as like a standard way of doing that sort of study. So it's hard to really make that case if you're only selectively doing that and making that argument when the results don't come out the way you want. It shows some kind of a bias. And he's been doing these pitching conspiracy theories since many, many years before he ever even got into politics. So don't get me started about that. So you got a lawyer whose job, his whole career, was to start with the conclusion and make the most convincing argument instead of starting with the evidence and building up what should be the thing you're arguing for. And I don't want to spend too much time on this slide because we're getting close to a quarter till. But the result of that is this. Instead of this scenario here, where you have a scientific consensus informing evidence-based policy, instead you have an ideologically driven one, where any evidence-based things slipping in there are mainly a result of pushback and the person who heads the HHS not being all powerful. So there's pushback. There are people that are fighting to keep certain things evidence-based, but they're fighting an uphill battle because they're not in charge. So that is why that topic is very important to me. And back to the scientists were wrong about X. Bottom line is that we don't know what aspects of our current knowledge will or will not turn out to be incorrect in the future until the evidence actually shows us what's wrong about our current views. So the maximally rational position for anyone to take at any given time is, at least insofar as the best of one's ability, to calibrate one's views to the weight of the scientific evidence at that given time, but to leave room for change, just to leave room for subsequent evidence, if it should arise, to amend that. But it doesn't make sense to try to play the lottery and say, well, I guess that this one that just happens to be the thing that's really inconvenient for me to believe is probably going to be the one of the things that gets thrown out in 20 years or something like that. Because you're using your system 2 thinking to justify a bias instead of trying to make the most accurate decisions. And if your beliefs about reality are more inaccurate than they need to be, then a lot of your decisions are going to be more poor than they need to be. And if we put that at the policy level, then it affects all of us in society negatively. And that's why I consider it to be a civic virtue to practice symmetric skepticism and to fight the tactics of science denial in the wild whenever appropriate. Whether that's for you means, just arguing in good faith with your uncle over Thanksgiving dinner or whatever. Just keep these ideas spreading out there. That's all I have prepared for tonight.